There we go in here. Okay, so following the same rules, we're going to work with addition and subtraction. Now, I'm going to add, remember how we had for multiplication and division, how we had the word least that described what we do? There are two steps for both adding and subtracting in order to figure out significant figures. I want you to write them down. Number one, line them up. That's a fancy way of saying line up the decimals. Now, subpoint of this, you may need to change exponents in order to line up the decimals. So number one, line them up. Line up the decimals. Number two, count columns to draw line O death. So let's do it. Let's now try a problem with this. And again, we're going to do an addition problem first. And I'm going to put in the corner, like I did in the previous video, the order of function is always units, then exponents, then sig figs. Now these get a little more tricky. I'm going to try and give you one that's kind of harder, but a little bit gentle at the same time. So here it is. We're going to use this number. 93764.123. Actually, I'm going to make that 1 into a 4. And we're going to use times 10 to the 4th centimeters. And we're going to add that to 37.61. Actually, I'm going to erase that 6 because I can. You can't. We're going to make it 37. Oops. This is me and my inexperience. We're just going to make it 37.1. And we'll make it times 10 to the let's make it to the 3rd centimeters. Okay, so now we're looking at our overall steps. First step always is to take care of the units. Now, the rules, if you remember back on our previous slide, it was on a different, I can't refer back to it, but you have to make them the same. You have to make your exponents and your units the same. So right now, don't we have the same units, centimeters and centimeters? So we're good. We're going to have centimeters overall. Let me tell you the horrible truth, though. I'm going to force you guys to memorize metric prefixes. And when you do, I may give you centimeters and meters. And your first step is going to be to convert them to the same unit. You guys get where we're going to go with this? Right now, we're not going to do that just because that's not the focus. But the centimeters need to be the same, and they are. Now we go to exponents. We have 10 to the 4th, and we have 10 to the 3rd. Don't we have to make the exponents the same? Yeah. Now we have two choices. We can either make the 10 to the 4th into 10 to the 3rd, or the 10 to the 3rd into 10 to the 4th. What I would like you to do is always take the second thing and make it into the first thing. Can we do that? So in this case, armed with our tools of lefty largy and righty reducey, lefty largy, don't we have to make this exponent largy by moving the decimal place over lefty one place? I'm going to go move my decimal place over one place and make this into 10 to the 4th. Now, by the magic that I have here with my smartboard, I'm going to erase this and write it again correctly. But remember the two steps? Wasn't the very first step to line up the decimal? In the steps for doing significant figures, wasn't it line them up? And I told you on the previous slide, wasn't it line them up, and you may have to change the exponent. So didn't we just change the exponent? So when we change the exponent, we have to now reline up the decimals because where the decimal place is before, it's not really lined up because I'm a crooked writer, but where it is before now is going to change because we've shifted it. So I'm going to change this now to 3.71. Notice how I've lined it up under the decimal here, times 10 to the 4th. Now, if you are comfortable enough, you in advance of doing this, you could actually write out one time like this and slide a decimal. So step number 1, in terms of our addition and subtraction, right here, I'm starring it because we've done it. We've lined up the decimal and we've changed the exponent. Step number 2, we've got to count the columns in order to draw the line of death. And this is the trickiness of it. And don't get confused. When we did multiplication and division, wouldn't we have counted up the least number of significant figures of these two, and that would have given me my answer? You may not do that with adding and subtracting. This is where students make the biggest mistakes, is they try and use the same technique every single time. So in this case here, we have to count the columns. And here's what I mean by counting the columns. It's kind of hard to see here. But we're going to count across until we hit the first column that has two things in it. Now, would you agree with me that there's two things in this, two things in this, two things in this, and then finally this one here, we reach a column where there's not a significant figure in both. So we go to the last column that has significant figures in both of them, and we draw the line of death right to the outside. So since we have these three columns that have, isn't this the last column right here that has significant figures in both? We draw the line of death right to the right-hand side of that. Are you with me? Go ahead. No. I'm so delighted that you said it. She asked whether or not we could just do the math and then take the least number. That's the rules for multiplication and division. And if you do that, you're going to be way off. Yes. I don't know exactly what you're saying, but let me finish doing this and we'll come back to it. Hopefully it'll be self-answered. So I'm going to put this 10 to the fourth here, and then we're going to do the math. Isn't this 3, 3, 1, 6, 4, 6, 7, 3, 9. I want you to take a look here. You realize that everything on this side is safe and this side is gone? Help me out here. Isn't there a significant number of significant figures that we have here over what we would have had if we just took the least number? And what's kind of cool about this is that once you've drawn your line of death, so we went through the process, we figured out the exponents, we counted the columns, we drew the line of death. Once you have the line of death drawn, every single problem is the same. We go to the number that's next to the line of death, and we ask it if it has a last request. Does it have a last request? Stay the same, right? Then that means that all the rest of these numbers here, all of them are significant. So I could stop right now, and do you realize that I go 937,646.13 times 10 to the fourth is a legitimate answer to this problem. But we like to put it in good form, right? So in order to put it in good form, just for the reader to be able to be pleased, wouldn't we have to slide this decimal place over 1, 2, 3, 4, 5 lefty? Wouldn't that make my exponent 5 largey? So I'm going to write this down below here. I'm going to erase because I can. And our new number is going to be 9.3764613 times 10 to the 9th centimeters. Now, I want you to pay attention here for a second. Don't we have altogether like 8 significant figures in our answer? Watch. If we'd have done the old method, wouldn't we have only had 3? So if you accidentally do your multiplication and division tables, methods, for adding and subtracting, do you realize you're going to be off by a gabillion significant figure spots? Okay, any questions for me here? So the question was, what do we do? How do we figure out the line of death, and what do we do with it? So when we're dealing with adding and subtracting, we start over here on the far left-hand side, and we work our way towards the right. And we basically look at each column, and we keep on going until we hit a column that has significant figures in both, and then we keep on going until we hit a column that doesn't have significant figures in both. So we have to go all the way to right here, this guy right here, before we hit a column that had numbers in both. Then we kept on going until we hit the last column that had numbers in both, and the rule is for adding and subtracting, you draw the line of death on the outside of that, which means that all of these numbers right here, they were saved. And the only number that's going to disappear is the lonely little guy that's the 0.3 over here. Now, we could have had, if the numbers had been shifted this way, couldn't we have had a lot of numbers that got chopped off? But you just count to the last column in order to figure out the number. Let me make this really clear here, though, and this is kind of important. Right now, this number right here that I circled, I'm circling it again. This is the correct answer. This is the correct answer, times 10 to the 4th. This number down here that I rewrote, this is it in good form. Is this answer right? Absolutely. Is this answer better? Yes. And this is what I want you to give me. I want you to give me the best answer down below. But you would get points for writing this. I just don't want to have to grade it. Here. Okay, so real quick. I've just done an example for addition, and I've grown weary. I could do the exact same thing. In fact, I could just cross this out and write subtraction And every single step is going to be exactly the same. In fact, we start off, we'd have to make the units the same, so we have the units the same, it'd be centimeters. The exponents we have to make the same, we make them the same. The only difference would be that when we get ready to do the math portion of it, instead of adding, we subtract. Everything else is exactly the same with the steps. Does that make sense? So I'm not going to do the whole subtraction version of this because it's exactly the same as this. And I'll be candid. The exponent portion of this is always a pain whenever you're dealing with adding and subtracting. Especially what if we have exponents that are like 10 to the 9 and 10 to the 4th? That's a real pain because when we have to slide it over 5 spaces, and then you can end up with numbers where they don't even line up with any significant figures. And that can be a problem.